Hello everyone, welcome back to the channel and welcome to the beginning of the end of this saga how to build a native cross-platform application from scratch using native languages. In today's video, we're going to make integration tests for our main view model. Without further ado, let's jump right in and let's go to the features test. Under features test, create a new folder. Let's call it main. Create a new class. Let's call it main view model test. As usual, we have to provide the needed dependencies to construct this main view model. We need authentication use cases, app use cases, wishlist, and the iDispatcher. Let's just do one simple test for the stream of data when it comes to application settings. Let's check that the main view model can stream application settings and user data. Let's try to seed some data and let's seed application settings. Let's arrange the GWT token and let's arrange the correct user data. And we have to act and let's define all the needed actions. In this particular case, we need to make sure that this section of our code has been called by adding here a flag. Let's call it, for example, onload application settings called. By default, it has to be false. The section where to check the credentials and the success states under auth success. Let's try to log something in the console. Let's say, for example, loading application settings. And here we have to change the value on load application settings called to true to make the assertion. With the same manner, let's log something, for example, checking credentials, and let's set on checking credentials called to true. Now under auth failed, we need to fail the test. In order to do so and to keep the flow consistent, we need to create an instance of type manual reset event slim. So what is basically manual reset event slim? In WPF, this class is used to signal between threads, meaning that we're going to send some data between threads and we have to wait for an event to occur, while another thread signals that particular event has happened. It's basically that we want to do here. We're going to wait for all of those events to finish in order to check that we have the auth failed. Let's try to log something here like the error message, and we have to do done event and set. By calling set on done event, it's going to make the state of the event signaled, and that's going to basically allow other waiting threads to proceed. Now, in case of auth success, we have to check if the user is not null. If the user is not null, we have to call or to change the flag on success called, and we have to make done event and set to mark the state of this event as signaled and to allow other waiting threads to proceed. I would like to add here a simple assertion before that. Let's make sure that the user should be equivalent to the correct user data. We have other actions. For example, on theme loaded, this is not mandatory to make this assertion because we have already tested the implementation of the repository and we have checked that we have the correct stream. Therefore, I'm going to omit trying to test something under the theme and whatnot. And let's go directly to the assertion. Next, we have to wait for a timeout. Let's set, for example, a timeout 5 seconds. Let's store this value under finished by calling done event and wait. Let's do 5 seconds. It's more than enough. Now we have to assert that this value finished is true. You can add here a message, for example, the async stream did not complete in time. For the next assertion, we need to make sure that the load app settings called is true, checking credentials called is true, and on success called is true. And we have to check that the value of the view model when it comes to dark theme is true, and the latest destination is home screen destination. And view model states latest visited screen should be of type home screen destination. And that's pretty much it for the test. Let's run the test. And the test passed, and that's very assuring actually. Under the splash screen, we'll be able to change the text loader. Let's check the output of the test. First things first, we have the loading application settings, then checking credentials. We are right now checking the credentials, and you can actually add here another log, done checking credentials. Let's run again the test. And that's pretty much it. As you can see here, we have the same output. After checking the credentials, done checking credentials. Now we are done with the integration test. It's time for end-to-end tests. In this particular file, I'm going to leave some comments that's going to walk you through how to install the needed dependencies. We're going to install, first of all, WinApp driver. Since I have already installed this in my machine, I'm not going to install it. This is the first step. After installing WinApp driver, run WinApp driver as an admin. This is basically the address that we have to attach to the configuration of the end-to-end test. Next, we have to create a test project that we're going to call Pocket Goods end-to-end test. Add a new project, X unit test project. Hit next, Pocket Goods end-to-end test. Next, and create. Let's delete this test. We don't need it. Now we have to configure the dependency that we have to add for this particular project. We need Appium WebDriver. So what is Appium WebDriver? It's basically a tool that uses the WebDriver protocol to automate testing. It's not necessary for applications. It can be used to test native or hybrid and web applications, even Android and iOS devices. It's going to allow us to write test scripts that interact with the UI. Let's install Appium. I'm going to change the version to the version number 4. All right, this is mandatory. For me, I'm used to the version number 4. Next, we have to install the Fluent assertion. And we need Core and Core UI. Core for the mock data and Core UI for the accessibility identifiers. Now our project is ready to go. Now we have a caveat here, actually. If you are trying to make some changes, keep that in mind, which is very important. If you try, for example, to add some changes to your app, let's say, for example, you have built a case or a test case for some in your application and the test failed. Normally, you're going to make some changes in your application. For example, add in some new colors and whatnot. Before even running the tests, you have to build the entire project before running the application in order to be reflected and detected under tests. All right, next we have to configure right now our end-to-end test environment. I'll create right now the structure of our project for testing, a dedicated folder for all the end-to-end tests, another folder for robot and for utilities, and that's all. We're going to create a parent class. We're going to call it end-to-end test that's going to handle all the configurations and running the application for testing. Inside end-to-end test, create a new class. Let's call it end-to-end test. First of all, we have to create an instance of Windows driver. It is the Appium Windows driver that controls the target application under tests. For the setter, it has to be private, null by default. If you want to show something in your tests, as we have done earlier, under integration tests, we're going to use the XUnit output logs during test execution. And we need to define the options of Appium options. That's going to hold all the configuration options for the Appium driver, such as the application path, arguments, etc. Now we have to copy the URL of the window application driver and the window application driver that you have already installed earlier. We have to copy the URL for the servers to communicate with Appium. Copy this under terminal. It's created as a private constant. Now we have to access the full path of the application. How to do so? We have just to build Control and Shift and B to build the solution. I have seen here the build failed. Gonna copy this. Click on the solution, right click and rebuild solution. We're gonna look for the folder that has the .NET 8.0 Windows. Since we have here the DLL, the exe file is gonna be in the same folder. Just copy this and let's create here a private constant. Let's call it app path. First of all, you have to add @ and followed by whatever content you have copied from the console. And instead of DLL, you have to add exe extension. Now let's add the constructor for this class. Under the constructor of this class, we're going to basically configure Appium. We want the access to this iTest output helper. Therefore, I'm going to add it as a parameter to the constructor. First things first, let's initialize the Appium options. Now we have to specify the application to be launched by Appium. Add additional capability, application, and app path. It's going to launch the exe file or the application from this particular path. Now we have to tell Appium that we are running tests on the Windows platform. Add additional capability. We have to set here platform. We are targeting a Windows application. Basically, we are done. However, if you do remember, in the code behind of the application, we need to set the environment variable to inject the needed dependencies. If this environment variable is not provided, we're going to inject the normal dependencies. Now we have to provide an argument to the application to enable a test environment. We have to add capability, app arguments, assign the arguments value, Pocket Goods environment test mode. And that's all for the configuration of Appium. Let's add the output equal output. As we have done under iOS and Android, we have to implement a function that's going to allow us to launch the application. In order to launch the application, we're going to use the driver. However, in order to prevent launching multiple driver instances multiple times, we have to check if the driver is not null. We have to make here an error return. Now we have to retrieve the application arguments from the driver's capabilities by using options and get capability application arguments. Why we do this? Because we want to check if we have provided the needed arguments for testing purposes. All right. If we haven't passed the arguments or the flag for testing, we're not gonna launch the application. You can think of it as a protection mechanism. Let's convert it to a string value. If this is not provided, we have to throw an invalid operation exception. App arguments are not set. Now we have to check that the application is being launched in test mode, as I've said earlier. If arguments contains test environment flag that we have assigned earlier. The source is Pocket Goods environment test mode, an ignore case. If it does not contain basically this flag, we have to throw an exception, invalid operation exception, telling, for example, the application arguments do not contain the required environment test mode or test flag. We have to initialize the window driver to start and control the application via WinApp driver. We have to set here the Windows application driver of type URI, and the timeout is to 5 seconds. And next we have to show the application or the main window. Basically, we have to bring the application window to the foreground. It's going to be useful when running the UI tests interactively. Let's implement this function, and we have to call it here actually. Let's call it, for example, bring application window. It's going to be either splash screen or the main window. Bring application window to front. First of all, we have to skip if the driver is not initialized. Now we have to retrieve the current window handle, basically in hexadecimal format, by using driver and current window handle. Now we have to check if the handler, which is a string, starts with the hexadecimal format. We will remove basically the prefix 0 and x, which is the hexadecimal prefix. Now we have to check if this handle string starts with 0 and x. For the string comparison ordinal ignore case, we're going to remove the prefix. Substring can be simplified. Let's see. All right, this is very good. Now what we have to do is we need to convert the string handle to an integer pointer to native window handle. We have to convert it to integer pointer from converting the signed integer 32 to 16 base. And finally, we have to use the native Windows API helper to bring the applications window to the front. Under util, I'm going to create a new class. Let's call it window helper. To set the window to the front, we're going to import the native Windows API function from user 32DLL. It's going to be used to set the specified window as the foreground, which is the active window. Let's call the function bring window to front. We need to pass an integer pointer to the handler window, show the window, and set it to the foreground. We have to import Windows API function from 32DLL. That's going to be used to show or change the state of the window, whether minimized or maximized or restored. First of all, we have to import the DLL user32 and static function. It has to be external actually, not set to foreground, but it has to be called show window. We need here the integer pointer for the handler window as well as native command show. And we have to show the window here, handler window. And as second argument, we have to set the constant to restore the window state, which is 9. Actually, I'm going to create it as a private constant, cw restore equal 9, and let's use it here. Now we have to bring the window to the front. Let's call this function set foreground, and we have to pass here the handler. Basically, it's going to make the window active. We're going to use the import from DLL32. Now let's come back to the end-to-end test. Now we have the handler, and we have implemented how to bring a certain window to the front to make it the active window, because it's very important. If we are under inactive window, we cannot make the assertions. And call bring window to front. Now we have implemented the function launch application. After finishing the test, we need to close the application. Let's create a public function. Let's call it close application. First of all, we have to check if the driver is not null. If it's null, we're going to do an array return. Next, we have to close the application's main window and terminate the driver session completely. And we have to set the driver to null, going to indicate to the application this session is no longer under test. You can pretty much right now think of a scenario, launching the application and waiting for the splash screen. And if you do remember, in the implementation of the code behind of the application, we're going to switch from the main window, which is the splash screen, to another window, which is the main screen, where we have the layout and whatnot. Therefore, we have to wait and switch to the main window. Let's create this function and let's prepare it for the scenario of our end-to-end test. Let's call it wait and switch to last main window. Actually, the challenge here in our application is handling multiple windows. And if you have added the login form and the register form in a dedicated window, you have to come up with a solution here in order to detect the current window. If you are not, as I said earlier, which is a rule of thumb, if you're not under the active window, Appium will fail to make the assertions. Now we need to set here timeout. Let's say, for example, 3.5 seconds. Now we have to give the application some time to finish loading the splash screen by doing thread and sleep timeout. Next, we have to switch to the latest or the most recent opened window, typically the main window after splash screen. By using driver, first of all, it shouldn't be null. The driver window handles count, it should be greater than 0. In this case, we have to switch to the latest window by doing driver and switch to window and driver, window handles, and last. Otherwise, we have to throw an invalid operation exception, no window handles found to switch to. We can go even further to switch to the window by a certain title. Let's check first of all that we have the driver. If not found, we're going to throw an exception. Next, we have to wait for a short period of time to ensure all windows are fully created. Now we have to retrieve all window handles currently managed by the driver. And we're going to loop over all the windows to look for this particular window that has the specific title. Now we can switch context to the current window handle by doing driver and switch to window and handle. And we can read the current Windows title by, let's store this value under current title by driver and title, which is the window. And we can check basically if the title matches the target. We're going to stop switching the window from the current window to another. Otherwise, we have to keep looking for this particular window. We have to check if the string equal to current title to break from the loop. And if no matching window was found, we're going to throw an exception. For example, no window found with the title. And if you decide basically to, instead of using the dialog of the WPF material design, and you switch to window, you have to do this. Basically, you have to look for a window by a title. We have to look for the window that has the title login and the window that has the title register. Let's fold this method. And for debugging purposes, I'm going to create here a public void function. I'm going to call it log message, not logo, but log. It should be output and right line message. And if we'd like to log the entire source of the current page, when it comes to the XAML, which is the content of the view or the component that you are trying to make the assertion on, we can use it actually if you want to have. I'm going to show you how. Let's create a function. Let's call it log page source using XML format. We can do that actually by using the driver. Let's check first of all if we have the driver. And we have to retrieve all the automation IDs currently available and visible in the UI tree. Let's create this function. This is optional. You can omit this section if you will. Let's check if we have the driver, and let's initialize the automation IDs using lists. Now we can access the source by fetching the API's current UI hierarchy as an XML representation. Let's store this content under page source using driver and page source. We're going to use XML document to load the XML structure of the traversal tree, and we can use XML document and load page source. Now we can get all the automation IDs from the XML representation by using a recursive method that's going to explore all XML nodes and extract the automation ID attributes. I'm going to call it traverse. I'm going to traverse basically a node of type XML node. We have to check if the node has an attribute that contains automation ID. We can access the attribute name. It starts here under automation ID attributes equal node and attributes using the array, and the key is basically automation ID. If this attribute is not null, let's access and store the ID from automation attributes and value. I'm going to assign only the non-empty IDs to the list by checking first of all that from the string and is null or empty ID. In this case, we can add the automation ID to the list. That's it for the inner function. Next, we have to continue traversing child nodes recursively by using for each, and for each child under the child nodes from node, we're going to call the traverse method. Now, if the document is null, we're going to return empty array, and you have to run the function traverse XML document and document element, starting from the root element. And we have to return the collected automation IDs. Now let's store the IDs under this list of type string, and let's get the full XML page source representation of the UI. Let's log first of all the page source by using log and page source for each variable ID in IDs. Let's log the ID. Let's keep it simple. You can add here something like, I don't know, log available IDs, for example. And let's add here something like, I don't know, page source. And let's add here an and to this and page source. The most important functions here under this end-to-end test are launch application, close application, and wait and switch to main window and switch to window by title. All right. I'm going to keep the functions actually if not needed. Perhaps you're going to use this in your projects. And that's pretty much it for this particular video. For the next video, we're going to implement the robot class and start basically our scenarios. I hope you have learned something new. See you in the next one, and happy coding.